Our focus today is to show to you how to prove trigonometric functions or trigonometric equations, okay, using the two-sided method. Meaning to say, we are going to simplify both sides, okay, equalize both sides of the equation. Unlike in the previous discussion, that in the a trigonometric function or equation, we just simplify the one side of the equation in terms of the other side. Now, what we are going to show to you is how to balance the equation by manipulating both sides of the trigonometric equation. And so again, before we are going to start, we have to be reminded with the different basic identities. These are the reciprocal identities, the Pythagorean identities, the quotient identities, the negative identities, because these are the most important identities in proving such trigonometric equation. Now again, first of all, we have to consider that both sides are in a complex form, complicated form. And so, meaning to say, we have to manipulate both sides, the left and the right of the equation. And so we have in here the problem to illustrate the proving of this trigonometry equation. We have this problem: cotangent theta plus tangent theta is equal to secant theta cosecant theta. Meaning to say, they are both considered to be a complicated one, and so we try to balance this one in terms of sine and cosine. Basically, in terms of sine and cosine. So the very first step is I have to define cotangent theta. Okay. Now and then define the tangent theta. Now, what is the definition of cotangent theta? We all know that that is cosine theta over sine theta. Okay, sine theta, and that is addition. How about the tangent theta? That is sine theta over cosine theta. Okay, now what about at the other side? You notice that when we are going to have this one, it will give you a problem, or it will give you a result of 1 over cosine theta. That is the reciprocal of what? Secant theta. And what about the reciprocal of cosecant? That is the same as 1 over sine theta. Okay? 1 over sine theta. Now, notice that we have to work as according to the operation we have in here. So addition of fractional form of the identities. So of course, if we are going to add fractions, we have to get the LCD. Okay, so what is our LCD in here? That is the same as the product of sine theta and cosine theta. Now after that one, this sine theta cosine theta divided by sine theta is the same as cosine, and multiplied by the cosine theta, it will give you cosine squared theta. How about this one? Sine theta cosine theta divided by cosine theta, it will give you sine theta multiplied by sine theta, it will give you plus sine squared theta. Okay, to continue the problem, you multiply also the other side. So that is the same as 1 multiplied fraction multiplied by a fraction. Multiply numerator to numerator, multiply denominator to denominator. So 1 multiplied by 1, it will give you a result of 1. Cosine multiplied by sine, it will give you sine. Okay, sine theta, cosine theta. I just tried to let it be the same with the denominator in here, the sequence. Okay. Now notice that when we continue under the Pythagorean theorem, sine squared theta plus cosine squared theta is equated to 1. And so, in this case, cosine theta plus sine theta is the same as 1. So, by substitution, we say now that the numerator is equivalent to 1, okay, over sine theta cosine theta, which is now the same as the other side. That is the same as 1 over sine theta cosine theta. So notice that they're already in the same form. They're already equal. So that if they're already equal, we are already done. We are already done proving the equation or the trigonometric equation that this cotangent theta plus tangent theta is the same as secant theta cosecant theta, okay, by this result. Okay, so that is how to at least prove trigonometric equation using double-sided method. When I say double-sided method, you manipulate the left side and manipulate at the same time the right side. Okay, there is a simultaneous manipulating of the both sides of the trigonometric equation. And so now you will notice now the result. The result is converted in terms of sine and cosine. Okay, so that is now the proof of our problem. Cotangent theta plus tangent theta is equal to secant theta cosecant theta. Okay, thank you. I hope you understand the sequence. Now we have another problem in here. Secant theta plus tangent theta over secant theta minus tangent theta is equal to 1 plus 2 sine theta plus sine squared theta over cosine squared theta. Now we will show that they are equal. Okay, we will prove that they are equal. And so how are you going to do this one? Notice that if I were to work on this, I will be simultaneously manipulate both sides. Okay, so let's try to have the proper proof of the problem. Notice that my numerator in the right side is considered to be a perfect square trinomial. So if that is a perfect square trinomial, now the question in here is, what is the binomial factor of this trinomial? So what would be the binomial factor? It is the same as saying 1 plus sine theta, okay, multiplied by 1 plus sine theta. So that if you will return this one to its original, that is the same as 1 multiplied by 1, it will give you 1. 1 multiplied by positive sine theta, it will give you sine theta. Sine theta multiplied by sine theta, 1 is the same as sine theta. So sine theta plus sine theta, it will give you 2 sine theta. Now what about this one? Sine theta multiplied by sine theta, it is the same as sine squared theta. Okay, so that is the binomial factor of our numerator. Now what about the binomial factor or the factor of cosine or the equivalent of cosine squared theta? Notice that this is the same as in the value of this one in the Pythagorean identities is the same as 1 minus sine squared theta. Okay, so that is the right side. Now, what about the left side? Okay, what about the left side? Notice that my secant theta is the same as 1 over cosine theta plus tangent theta. Tangent theta is the same as what? Okay, sine theta over cosine theta. So that is my numerator. What about the denominator? Same. That is secant theta is the same as 1 over cosine theta minus. So minus. How about this one? That is still the same as sine theta now over cosine theta. Okay? So that is the left side. Now, notice that when we continue the problem, now in here, in the numerator of the left side, we have to add according to the operation involved. So when we are going to add, notice that they have the same denominator. So what will we do is, we copy the denominator, that is cosine theta. Okay? And so, because that is the rule on the addition of fraction with the same denominator. Copy the denominator and then add their numerator. So that is the same as 1 plus sine theta. Okay? Sine theta. Now, what about the numerator? Same, add the denominator. You will notice that my denominator has the same denominator. So, if we are going to subtract that one, we copy the denominator cosine theta. And after that one, subtract their numerator. So, numerator is 1. 1 minus sine theta. Now, what about at the right side? At the right side, notice at the right side, for the denominator, this is actually the difference of 2 perfect square. So in here, this one is can have a binomial factor. Now, what is the binomial factor of that one? That is the same as 1 minus sine theta multiplied by 1 plus sine theta. Okay? So, this equation actually, this denominator is actually likened to an expression in the algebra that is the same as x raised to 2 minus y raised to 2. Okay? With, of course, a binomial factor of the same as, like this one, x minus y multiplied by x plus y. That is the same as in the denominator we have in here. Okay? Now, notice that our numerator, we copy, that is the same as 1 minus sine theta, then 1 plus sine theta. Okay? Sine theta. So, if you try to evaluate, we can cancel out some expression. So, this one, this denominator can also be canceled out in here. Okay? So, what is left now, if you will notice, what is left now is 1 plus sine theta over 1 minus sine theta. Now, what about at the other side? What about at the other side? Notice that this is division of fraction. Now, so that when we divide fraction, we get the reciprocal of the denominator and then proceed to multiplication. So we copy first the numerator, that is 1 plus sine theta over cosine theta. And then after that one, we get the reciprocal of this one. What is the reciprocal? 1 minus sine theta and then another cosine theta. Notice that after getting the reciprocal, proceed to multiplication. So that if you will notice, the cosine in here will cancel out. What is left now? If you notice, what is left now is 1 plus sine theta, 1 plus sine theta over 1 minus sine theta, which is equated at the right side. 1 plus sine theta over 1 minus sine theta. So that is the proof of our problem. So notice that they are the same, meaning to say they are of the same form, and thus we can say now that secant theta plus tangent theta over cos secant theta minus tangent theta is the same as 1 plus 2 sine theta plus sine squared theta over cosine squared theta. So I hope you followed the step-by-step or procedure of proving this trigonometric equation. So we have how many steps? So in here we have at least 3 to 4 steps. Okay. So again, when we prove any trigonometric equation, we have to go over again with the basic identities, and then after that one, we just follow the dictate of the operation involved. So addition, subtraction, division, and multiplication. So there is none that is very hard in here if you will memorize the basic identities. Okay, again, I hope you understand how to prove such trigonometric equation using double-sided method of proving. Thank you. The next problem we have in here is prove that the sum of the quotient cosine theta over secant theta and sine theta over cosecant theta is equal to secant squared theta minus tangent squared theta. Now, how do we solve for this problem? So in order to solve for this problem, again, we treat this one to be, we treat both sides to be complicated. Thus, in here, we have to make use of the double-sided method of proving. Meaning to say, we manipulate the right side, we manipulate the left side simultaneously. And of course, we have to apply again the basic identities of the trigonometric expression. Now, notice that when we are going to look for this, for the problem, or solve the problem, we see to it that both sides will result to both or same form. Okay, it will result to same form. So let's try to do it step by step. Now in here we have to define the secant. Okay, secant theta. What is secant theta? That is the same as 1 over cosine. 1 over cosine theta. Okay? Remember that this must be the division, this one. Okay? Plus sine, okay, sine theta divided by the reciprocal of cosecant, which is the same as 1 over sine theta. Okay, over sine theta. Now what about at the other side? Notice that secant squared theta is the same as 1 over cosine squared theta minus tangent squared theta is the same as saying sine squared theta over cosine squared theta. Okay. Now, notice that in here, in the left side, that is division of a whole number and the fraction. And so how are we going to divide fraction divided by a fraction or a whole number divided by a fraction? We get the LCD of the, we get the reciprocal of the denominator and then proceed to multiplication. So this is the same as cosine theta over 1, this one. Okay, multiplied by the reciprocal of 1 over cosine, which is the same as cosine theta over 1. Okay, now what about this one? The same procedure. That is the same as in here, that is the same as sine theta over 1 multiplied by the reciprocal. That is the same as, what is the reciprocal? Okay, sine theta over 1. Okay, sine theta over 1. Now what about at the other side? Notice that subtraction of fraction with the same denominator. And so how do we subtract a fraction with the same denominator? We just copy the denominator, cosine theta, and then subtract their numerator. Subtract the numerator. Now what is that now? 1 minus sine squared theta. Okay? Sine squared theta. Now notice that in here, we continue now cosine multiplied by cosine. Cosine multiplied by cosine, it will give you cosine squared theta. Okay, 1 multiplied by 1, 1. Okay, so over 1 yan. And then plus, how about this one? Sine squared theta. Okay, over 1. Okay. And of course, let's continue. This is the same as 1 minus sine squared theta over cosine squared theta. But remember that when we have the Pythagorean identities, the sine squared theta plus cosine squared theta will give you a result of 1. Okay? So meaning to say, when we are going to have this one, the result of cosine squared theta plus sine squared theta is the same as, for the next step, this one is the same as 1. Okay? 1. Now what about in here? Okay, what about in here? 1 minus sine squared theta must be simplified with the new definition of this one. Again, applying the trigonometric identity or the Pythagorean identity, cosine squared theta can be derived from this. Okay, so cosine squared theta has a value of 1. If you put that one, it will give you negative sign. Okay, sine squared theta. And so by substitution again, we replace cosine squared theta with 1 minus sine squared theta. 1 minus sine squared theta. And so with that, you notice that they are but the same. When we divide them, it will give you to a result of 1 is the same as 1 now in here. So that would be now the proof of the problem. Okay? So meaning to say, we can now say that cosine theta over secant theta plus sine theta over cosecant theta is really equal to secant squared theta minus tangent squared theta by this result. Okay, so by this result, so meaning again that is the proof of the problem. So now notice that both sides are being manipulated, simplified, and notice that at the end they are all equal. Now